Hello students, welcome to fifth lecture of chemical bondings and molecular structure. In previous lecture we discussed about covalent bondings and its drawback. Now it is time to move on second type of bond, electrovalent or ionic bonds. So in previous points, Costa-Lewis approach, we already discussed about this type of bonds. Their theories was mainly based on assumption that electrons are either lost or gained by the atoms to fulfill their octets, and it is called electrovalent or ionic bond. So from the Cossel and Lewis treatment of the formation of ionic bond, it follows that the formation of ionic compounds would primarily depends upon. Now some conditions are mentioned. First, ease of formation of positive and negative ions from the respective neutral atom. That means, suppose let us compare two different situations. Suppose you have a carbon and a sodium. So obviously nature of sodium is metallic. That means it normally loses electron, but carbon is non-metallic element. So that means usually carbon do not release or donate electrons. So it depends on the nature of atom, how easily it accepts or loses electron. Second point, arrangement of positive and negative ion in the solid, that is the lattice of the crystalline compound. Now lattice is arrangement of solid particles or constituent particles of given solid in proper manner. Here is an example of lattice. As we can see, we have two different type of atoms or ions in this structure. It is a microscopic image of solid. So as we can see, two different type of sizes are compatible with each other. If sizes are too small or too big to be compatible with each other, then they cannot form this type of proper arrangement inside the solid. Here is a quite brief look or a separated look so that we can properly see how these particles are arranged. Line between two different particles actually represents they are in contact, as we can see in this image. If we talk about this particle, first particle and the adjacent particle to it, then they are in contact with each other. As we can see, they are actually touching each other. So to bring out geometrical shape from them, we can separate them out, and if they are in contact, then we will draw a line to connect them so that we can see proper geometrical shapes like this. So as we can see, adjacent particles are actually in contact with each other. To represent actual arrangement of these constituent particles, we are joining them with lines, straight lines. So actually straight line represents they are in contact, and this is called lattice. So second point, arrangement of the positive and negative ions in the solid, that is the lattice of crystalline compound. So lattice, that means as we see in the image, arrangement of constituent particles in proper manner. The formation of positive ion involves ionization, that is removal of electron from neutral atom, and that of a negative ion involves the addition of electron to the neutral atom. That means for negative ion it will be electron gain, for positive ion formation it will be ionization. So as we can see, simple reactions are mentioned here. First we have metal in gaseous state. You have to convert metal into gaseous state first to lose electron. It cannot release electron directly from solid state. So metal in gaseous state gives metal ion plus it releases electron. So it is ionization, and energy involved in this reaction is called ionization enthalpy. X gas gains that electron released from the metal, and it gives X minus gas. Because of print mistake, negative signs are not mentioned here, but you can get it. Okay, so these are the negative signs. So second reaction gains electron, that's why energy involved in it is called electron gain enthalpy. Now positively charged metal ion and negatively charged anions or gas will combine with each other to give us ionic compound. The electron gain enthalpy delta EGH is the enthalpy change. Now description of this will be discussed in thermodynamics unit. What is enthalpy and what is electron gain? When a gas phase atom is in the ground state, gains an electron, it is called electron gain reaction. And enthalpy, that means energy change involved in it, is called enthalpy. The electron gain process may be exothermic or endothermic. The ionization, on the other hand, is always endothermic. Whenever electrons are released, it requires energy always. Electron affinity is the negative of the energy change accompanying electron gain. Obviously, ionic bond will be formed more easily between elements with comparatively low ionization enthalpy so that it can release electron easily, and element with comparatively high negative value of electron gain enthalpy so that it can accept electron easily. Most ionic compounds have cations derived from the metallic element and anions from the non-metallic elements. The ammonium ion NH4 plus made up of two non-metallic elements is an exception. Otherwise, mostly metals and non-metals will be used in ionic compound. It forms cation of a number of ionic compounds. Ionic compounds in the crystalline state consist of a orderly three-dimensional arrangement of cation and anion held together by the Coulombic interaction of energy. Now, three-dimensional arrangement, that means lattice formation as we seen in previous images. It represents three-dimensional arrangement of constituent particles in ion. This compound crystallizes in different crystal structure determined by size of the ions, their packing arrangements and other factors. Now all of these points will be discussed in detail in 12th solid state unit. Okay, lattice formation, different type of lattice arrangement, size of particles, which matters during the different type of arrangement and systematic arrangement. The crystal structure of sodium chloride NaCl or rock salt for the example is shown here. Okay, so keep in mind this structure will be useful in standard 12 solid state unit as well. Okay, so keep in mind and remember this structure. And maybe you already see this structure in previous standard 10 as well. In ionic solids, some of the electron gain enthalpy and ionization enthalpy may be positive, but still the crystal structure gets stabilized due to the energy released in the formation of crystal lattice. That means which reactions are possible or spontaneous, whose energy will be in negative, enthalpy is negative. If enthalpy of reaction is negative, then we can say that it is spontaneous. That means it will occur on its own. And if enthalpy of reaction is positive, that means it requires energy. It cannot occur on its own. So if here we have two different type of reactions, electron gain reaction and ionization reaction. That means positive ions are formed due to the ionization reaction, negative ions are formed due to the electron gain reaction. As mentioned, electron gain may be positive or negative in term of enthalpy, but ionizations are always positive. So let us use one example to understand this point. So as we can see, we have a reaction in which A forms positive ion, and during this enthalpy value is plus 100. That means this reaction requires 100 points of energy. Second reaction is electron gain reaction, and enthalpy of this reaction is minus 50. That means this reaction will release 50 kilojoules or 50 points of energy during this. So if we combine these two reactions, that means A plus B gives A positive B negative, that means AB molecule. In this reaction, net energy value of whole reaction will be, from first reaction it requires 100 kilojoules of energy, from second reaction it releases 50 kilojoules of energy. That means enthalpy of this reaction will be plus 50. That means this reaction requires external energy support to fulfill or to complete itself. Now when they forms solid compound, as mentioned earlier, we have gaseous metals and gaseous ions in this situation. So finally when these gaseous ions or molecules forms a solid crystalline structure, this is called lattice formation, and in this reaction again energy will be released. That means let us say lattice enthalpy of this reaction. That means when gaseous molecules are converted into solid particles or solid crystals, they also release some energy. And let us say released amount of energy is minus 100. So we have to put this value in this as well. So if you put minus 100, that means you will get overall enthalpy in negative terms. So that means negative value represents this reaction will be spontaneous. Same type of example is mentioned here again. So first of all, formation of Na plus from Na, it requires 495.8 kilojoules of energy, while formation of Cl minus releases 348.7 kilojoules of energy because its enthalpy is in negative. So that means if we sum up these two, then you will get 147.1 kilojoule in positive term. That means this reaction is not spontaneous. It requires 147.1 kilojoules of energy per mole. But when NaCl solid is formed, then it releases high amount of energy. As you can see, enthalpy of formation of NaCl from Na plus and Cl minus is minus 788. So all the requirement, that means 147 for previous requirement, will be fulfilled from this released energy, and our reaction will become spontaneous. That means absorbed energy will be fulfilled from the released energy. Thus, a quantitative measure of the stability of an ionic compound is provided by its enthalpy of lattice formation and not simply by achieving octet of electrons around the ionic species in gaseous state. Okay, so that means octet rule has some effect on this, but it is not quite significant in this type of formation. Since the lattice enthalpy plays a key role in the formation of ionic compound, it is important that we learn more about it. So let us talk about lattice enthalpy. The lattice enthalpy of a ionic compound or solid is defined as the energy required to completely separate 1 mole of solid ionic compound into gaseous constituent ion. That means if you have 1 mole of NaCl, then energy requirement to completely convert it into gaseous state is called lattice enthalpy. So we can say that lattice enthalpy is separation of solid particles and conversion into gaseous state. For example, lattice enthalpy of NaCl is 788 kilojoules. That means if you have 1 mole of NaCl in solid state, and if you want to vaporize it or if you want to convert it into gaseous molecules, then you need 788 kilojoules of energy. So the process involves both the attractive forces between the ions of opposite charges and repulsive forces between the ions of like charges. The solid crystal being three-dimensional, it is not possible to calculate the lattice enthalpy directly from the interaction of forces of attraction and repulsion only. That means it is three-dimensional. From all the direction, it is feeling one particle is feeling attraction or repulsion because all the sides are filled with other particles as well. Same type of different type. In lattice, that means if we observe this image, as you can see, suppose let us concentrate on particle present at the middle. So this particle is surrounded by other type of particles from all this direction because this is three-dimensional arrangement. Okay, so as you can see, it has multiple same or different type of particles around it. Same type of effect will be observed for other particles in this three-dimensional arrangement as well. Okay, this is a small portion of solid to represent geometrical shape, and you can see in this image as well. So each and every particle is surrounded by other particles of the same type or different type. That's why it feels repulsive or attractive forces. But we cannot predict the energy value directly from the repulsion between two adjacent atoms or attraction between two adjacent ions. And that's why factor associated with the crystal geometry have to be included in the lattice energy calculation as well. Okay, so if you find any difficulty till this point, feel free to ask. And about lattice and different type of arrangement of lattice in 3 dimension, we will discuss or learn about it in detail in standard 12.